Okay, in this video we are doing part 2 of assignment 4 of my Calc CD class, which is Multivariable Calculus. We're doing Lagrange Multipliers. We're going to find the absolute max, absolute min of this function given the constraint x to the fourth plus y to the fourth equals 1. Let's do it. So we got to find the gradient of f. I always want to say partial f. I don't know. The gradient of f, that's going to be partial x comma partial y, so 2x comma 2y. All right, now we create a function called g, which is just take the constraint, move everything to one side, and set it equal to 0, basically. So g is going to be x to the fourth plus y to the fourth minus 1, and g is always equal to 0. It's part of the formulation of Lagrange multipliers that you need to do that. You can get away without doing it if your professor or teacher is not really picky about your work. We now need to find the gradient of this thing. So the gradient of g is partial x, which is 4x cubed, comma partial y, which is 4y cubed. All right, so things are looking very symmetric here. The whole Lagrange thing hinges upon this equation. The gradient of f is lambda gradient of g and the constraint function. If you forget the constraint, you're going to be in trouble because you won't have enough equations. You'll have too many unknowns. So gradient of f is lambda gradient of g is going to give us two equations in three unknowns, right? We get 2x is lambda times 4x cubed, and we get 2y is lambda times 4y cubed. And then we also have the constraint. So x to the fourth plus y to the fourth is 1. So this is the system we need to solve. Typically, you want to get rid of lambda as soon as you can. So I'm going to say that lambda is... So I'm going to say it's 1 over 2x squared, where I've definitely broken a rule here, because what if x was 0? That's going to come back. We need to remember, like, x could be 0. That would definitely make this true, right? You would get 0 equals 0. By dividing out an x, I said basically x is not 0. You can't divide by 0, right? So I said, like, this is kind of if x is not 0. This scenario holds true. And then y is going to have the same caveat, where, like, I'm dividing by essentially something that could be 0, so I have to worry about that later. But two things equal to lambda, so they're equal to each other. So 1 over 2x squared equals 1 over 2y squared, which means x squared equals y squared. And then we can factor this, like move everything to one side, and then difference of squares, so x plus y, x minus y, which gives us either x is equal to negative y or y is equal to negative x, or y is equal to x. Or let's go back and worry about that thing. We said by dividing by x and dividing by y, we said that they were not 0. So at this step, we should have immediately said it is possible that x is equal to 0. It is also possible that y is equal to 0. Those are definitely things that would make those equations true. So we need to worry about those. All right, now, if y is equal to negative x, we're going to use the constraint. That'll give us x to the fourth plus x to the fourth is equal to 1, which means that 2x to the fourth is equal to 1, which means that x to the fourth is 1/2, which means that x is this kind of like gross plus or minus 1/2 to the 1/4. And I wish there was a better way to write that. I guess like the fourth root of 1/2 maybe would have looked a little better. We got to keep going though. So if y is equal to x, we get essentially the same thing, right? So if y is equal to negative x, we get plus or minus 1/2 to the 1/4. If y is equal to positive x, we get x is plus or minus 1/2 to the 1/4. Also, we need to consider x is 0 and y is 0. So if x is 0, we get y to the fourth is equal to 1, which means that y is plus or minus 1. And then if y is 0, we get x to the fourth equals 1, which means x could be plus or minus 1. All right, so a lot of information here. So I'm going to copy those over, like everything that I wrote at the bottom there, those 4 lines, so we can deal with this. All right, so if y is equal to negative x, we got plus or minus 1/2 to the 1/4, right? So that'll give us 1/2 to the 1/4, and then negative 1/2 to the 1/4. That'll also give us negative 1/2 to the 1/4, comma 1/2 to the 1/4, right? Because y is equal to the negative or the opposite of whatever x is. So that's from the first one. From the next one, so here, we know that y is equal to x, right? So if x is 1/2 to the 1/4, y is also 1/2 to the 1/4. If x is negative 1/2 to the 1/4, y is also negative 1/2 to the 1/4. So you have to be really careful when you're getting your points out of this. It's not hard. It's just like you have to think really precisely about it. So maybe it is hard. Maybe that's the definition of hard. I don't know. But be organized about it and you can do this for sure. From our third line, x is 0 and y is either plus or minus 1. So we get 0, 1 or we get 0, negative 1. And then from our fourth line, y is 0, x is plus or minus 1. So we get either 1, 0 or negative 1, 0. So we have 6 points that we got to deal with, 4 of which are disgusting. All right, so we have to take these and plug them in. Did I use a calculator? Maybe. You don't really need a calculator. You can actually do the work. But at 0, 1, 0, negative 1, 1, 0, and negative 1, 0, you just get 1 every time. You can see that. We're just plugging into x squared plus y squared. And then at our plus or minus, I'm just going to combine everything. At our plus or minus 1/2, 1/4 points, we are always going to end up with 1/2 to the 1/4 squared, which is 1/2 to the 1/2. And so you just get 2 of those every time. So you get 2 over root 2, which is just root 2. So one of these is the biggest and one of these is the smallest, guaranteed. So the absolute minimum is 1 and the absolute maximum is root 2. And we solved the problem. So what we really have to do is be very careful about finding the ordered pairs. The actual work wasn't that bad. All right, I'm going to look at number 11, which is the last one on this assignment. And also, I do not want to solve 3 equations in 3 unknowns, 4 equations in 4 unknowns, rather. So I'm going to use a calculator on this, but I will set it up. So we have f of x, y, z is 3x plus 2y plus 4z. X squared plus 2y squared plus 6z squared is 1. So we need the gradient of f, which is just partial x, partial y, partial z. You can do this with as many things as come at you. And then our constraint we redefine as g, but I'm just going to find the gradient this time. So we need partial x, which is 2x, partial y, which is 4y, partial z, which is 12z. Okay, and then our system of equations comes from gradient of f equals lambda gradient of g and the constraint, which means we get 3 is equal to lambda times 2x, 2 is equal to lambda times 4y, and 4 is equal to lambda times 12z. And looking at that, I'm thinking, I could probably solve this by hand. I just don't want to. And yeah, I mean, I probably could, but maybe I couldn't. X squared plus 2y squared plus 6z squared is equal to 1. That's our system. Okay, so what I've done is, I don't know, depending on your definition of cheating, I've used a calculator to solve this system. So let's go. Here's what I typed in. I want to solve that system. I always use k as lambda on my calculator. So 4 equations, 4 unknowns, x, y, z, and k. Also, I stipulated k is greater than 0 because I didn't want it to spit out annoying things to begin with. So I get these. There were just too many answers, I guess, is what basically happened. And then I stipulated k is less than 0, and it spit out this. And then I took those and I just plugged them into the function, and it gave me this. And so this is definitely the absolute maximum, right? Is root 123 over 3, and the absolute minimum is coming from this point. If I had to guess, I would say there are probably more than just that point generating those values. There's probably a lot of plus minus things going on here. But anyway, that's it. I would accept that from my students. So I hope this was helpful and good luck.